Hi everyone, thank you for joining me on this parent engagement. My name is Claire Crisp and I am the Primary Maths Curriculum Coordinator here at WSO. Today I'm going to talk to you about how we are supporting your children's problem solving skills in maths here at WSO. I'm going to talk through some of the different strategies and approaches that we are using which will support your children in maths, especially their problem solving. So to begin with, it's really important that we understand what we mean by problem solving when we're talking about maths. To summarise, problem solving is the ability to apply the maths facts and knowledge and skills that we have to a variety of situations. And as you can see from these couple of quotes here from various research, it's not just about answering word problems and knowing facts, but it's about that ability to apply knowledge and skills to familiar and unfamiliar problems. To give some context as to how we teach maths in the primary phase at WSO in general, I wanted to share this diagram with you. This is the mastery model. And when we're teaching for mastery, we're talking about students acquiring a deep, meaningful, long-term understanding that they're able to apply and use quite flexibly. So you can see that there are four main components. So we develop students' understanding of how representations and structures can be used to show their mathematical understanding, which then supports their mathematical thinking and reasoning, as well as their fluency, so using their number facts, the times tables facts, and also being able to do these with variation. So for example, understanding that numbers can be represented in various different ways, as can problems. So by doing this then, we are able to help support the students in making connections. As you can see, is a key part of all four of those components, and it is making these connections that support students in being able to use their maths knowledge and skills flexibly and to apply it to problems. Previous approaches then that we have used have always been based on this model here, which has got four main steps, which is number one, to understand the problem, two, to be able to devise strategies for solving the problem, then being able to carry out the strategy, and finally check the result. And we've been used to using many acronyms over the years to make these stages child friendly. So you can see on the slide here that this is rucksack, and this is one that many of the students at WSO are very familiar with. So we've got rucksack, so read, understand, choose, solve, answer, and check. Similarly, carrying on from the previous slide, here is another example where an acronym has been used to support problem solving in maths. So this one is called CUBES. So again, circle the numbers, underline, box the key information, eliminate what we don't need and evaluate what you do need, and then finally solve. However, there is a problem with these acronyms and these types of models, which is what does it actually mean when we ask the students to read and understand? And how can we teach the students these key steps? How do you teach students to understand problems? And then equally, how do we know if students have understood a problem so that they can then go on to solve it and check it appropriately? This is why here at WSO, we are adopting a new approach to problem solving in maths. We are now introducing our students to the three-read approach. The problem is read through 3 times with a different goal each time, and I will share those in depth with you shortly. The approach deepens student understanding by surfacing the linguistic clues, so by focusing on the language and ensuring that students understand the key words, the questions, and the general vocabulary, as well as the mathematical clues. It focuses attention on the importance of understanding the problem rather than rapidly trying to solve problems. And it basically breaks down that read and understand element of rucksack and cubes into a systematic but child-friendly manner. So I'm now going to share some examples of what this will look like to the students. During the first read then, this is when the problem is first presented to the students. During this first read, the goal is simply to comprehend the text and understand the context of what's going on. So it doesn't involve the numbers or the actual mathematical question itself, and at this point teachers will often conceal and hide the numbers so that the students can focus on just the vocabulary. Teachers will use this as a time to ask the students to present it in their own way, or even act it out, so that then the students develop that understanding of what's physically happening. For example, if they start with an item and then at the end they no longer have the item, or they have fewer. This is also a great opportunity for teachers to recap with their students previously learned vocabulary to make sure that that understanding is secure, as well as discussing any new, tricky or unfamiliar vocabulary which actually may act as a barrier to the student's understanding and ability to continue with solving the problem. So to summarise, this read is all about understanding the language and the context. Once students do have a secure understanding of what the story is and what all of the vocabulary means, so for example, if a word such as less is presented, if students understand that that means the end result is going to be a smaller value, we move on to the second read. And the goal of the second read then is to start to present the numbers, but we don't focus on any questions yet. We just present the key numbers and begin to comprehend the mathematical structure of the problem. So children at this stage are encouraged to think about the relationships between the numbers and represent these visually, which I will demonstrate in an example shortly. Teachers might also use this as an opportunity to challenge students by asking them to create alternative questions. This is a really fantastic way for us to extend and challenge students further by them showcasing their understanding of what makes a good mathematical question and what doesn't. Then we reach the third read. After the students have got a secure understanding of the context and the story and the vocabulary, and they've got a good understanding of which numbers are important and what the relationship between those numbers are. So the goal of this third read then is to consider different ways of actually approaching and solving the problem. So considering which operations to choose and how many steps will be required. So they are encouraged to consider what would or wouldn't work and exploring the importance of efficiency and accuracy. Very often students will want to rush through and do it in the most efficient way that they possibly can. So we explore the importance of being able to work efficiently, but also checking that these methods are also accurate. Again, as I already mentioned, we can here at this point present other mathematical questions that the students have created or other ones that we as teachers want to present to them, perhaps to challenge them even further. And this is where it's important for us to be able to really analyse and dig deeply into the problem. And this is where mastery maths is achieved, is that deeper level of understanding and being able to take our knowledge and our facts and our skills and apply them flexibly. So over the next few slides now, I'm going to go through an example of what this would look like in Key Stage 1 and in Key Stage 2. So first of all, this is an example of a Key Stage 1 problem. As you can see on the left, I have covered up the numbers and have just presented the problem. So this is the first read where we're going to focus on just the story and the language and understanding what this means. So I've got Annie finds a coin. She puts it with her other 3 coins. Does Annie have enough to ride the toy train? Explain why. So the types of questions then that the teachers would be asking their students at this point, you can see on the right. What is this situation about? Can you put it into your own words? Are there any new or tricky words you don't understand? Do you need any more information? So at this point as well, the teachers will be encouraging students to think about what is going to happen. If Annie already has a coin and she puts it with her 3 other coins, does that mean we are going to be looking for an answer that is greater or less than? And it's ensuring that students have that contextual understanding of if you put 2 groups of things together, you're going to have a larger amount. Something else I would just like to point out at this point is you will see the emojis on these slides. This is to try and make this a more familiar routine for the students so that when they see these emoji symbols, they understand that it's time for read 1, read 2, read 3. Like I said, just to build that familiarity as they've had previously with rucksack. Then we come on to the second read. So this time we will ask the students, what extra information do we now have? And they will hopefully be able to identify that we now have introduced the numbers. At this point then we will talk about, do we need all of these numbers? Are there any that are irrelevant? If we do need them, what do these numbers represent? And how are they related to one another? So this is where we focus on the students representing it visually, or it could be abstract. It could be in a written number sentence. You will see on the slide here where it looks like there are just 5 circles there together with 20 pence written 4 times and a question mark at the top. This is a model that all of our students at WSO are very familiar with, even from year 1. It's the part-whole model. And this really helps students to understand the relationship between numbers. So if we go back to the problem, Annie finds a 20 pence coin. She puts it with her 3 20 pence coins. At this point then we can ask students, are those numbers the whole amount, or do they represent just part of it that makes the whole? And the students have a very good understanding of differentiating between parts and wholes. So this would be something that they would do naturally. So at this point then, we would then begin to discuss the relationship between the numbers and begin to think about what we might do with those numbers. And then following on from the second read, we now move on to the third read. So at this point, the students have got a good understanding of the story and the vocabulary associated with the problem. They also have a secure understanding of which numbers are important, what the relationship between the numbers are, and what each number represents. So at this point during the third read, this is when the students consider how they could use the numbers to actually solve the problem. Again, although it may seem like we are slowing students down, we want the focus to be on solving problems in a systematic way rather than simply rushing to get answers. So we will ask students which steps and how many steps will be needed to solve the problem. And although it may sound like we are slowing students down, this is actually a really important step, and we're able to extend students by asking them whether there are any other ways that they know of to get the same answer for the problem. By slowing them down and asking students to reflect on the different strategies and to decide which they prefer and why is a really important way in which we can ensure students do gain that mastery understanding, because they're able to analyse their knowledge and their skills to be able to then in future choose the most appropriate based on their understanding of the efficiency and the accuracy, which shows that they have got that flexible and deep understanding. So this is an example here of how we would like the students to break down their working out. We would encourage students to initially work together on this. It encourages collaboration, it encourages that use of vocabulary and explaining to each other. Again, being able to explain and teach one another different strategies is considered another form of mastery understanding. So as you can see here then, we've got step 1, add the 4 20 pence coins to see how much money she has. And underneath then, you can see that I have shown 2 different ways that the students may discuss for ways in which they may solve this. So for example, 20 plus 20 plus 20 plus 20 equals 80, or an alternative approach that some students may discuss is the fact that they know 2 times 4 equals 8, so 20 times by 4 equals 80. Showing that they have that understanding of related facts. Then moving on to step 2, compare how much money she has and the cost of the ride, so that understanding that 80 pence is less than 90 pence. So we would encourage students to break it down like this. Not necessarily writing the sentences, because we don't want the focus to then move away from understanding the mathematical problem, but it's really helpful that students do break it down and discuss it in this way. And then similarly, here is an example then for Key Stage 2. So again, the problem has been presented where there are no numbers. This is just about the language, the vocabulary, and the context. It does help a lot, especially as the problems become a lot more complicated and there are a lot more steps involved in order to solve it, for the students to act it out. So again, looking at those key questions, what is the situation about? Can you put it in your own words? Again, encouraging that use of collaboration and vocabulary with partners. Are there any new or tricky words you don't understand? And is there any information missing? Moving on to the second read, we have exactly the same problem, but now we have the numbers. The students have that secure understanding of the context, the story, the vocabulary, so we've presented them with the numbers. At this point now, we're going to discuss, do we need all of the numbers? If not, which ones do we need? Which ones can we actually eliminate and why? How do you know that? And what do they represent? How can we represent the numbers to show how they are related? And again, this is something the students are very good at doing. So here are some of the different representations that our students in Key Stage 2 might use to solve this problem. Starting on the left, we have a bar model. Bar models are fantastic for showing the relationship between numbers. So as you can see, from the problem, we were told that Whitney had double the amount that Mo did. So very quickly, we were able to build this bar model where Whitney literally has double. So she has 2 times that. Then we're able to represent that Teddy has half of this, but we're yet to figure out what that is. It's also worth noting at this point that where I've written some key sentences and key facts, for example, double equals times by 2, although they aren't visual pictures or models, they are still helpful representations and facts that we are encouraging students to refer back to and use when problem solving. And then again at the bottom there, we've got our part-whole model, where this time the students have been able to identify that one of the numbers we were given was actually the whole, the total amount, and we needed to then calculate what one of the parts are. And then on to the third read, once the students have established how they want to organise the numbers in a way that makes sense to them, we then look at what we're actually going to do with those numbers. Again, looking at how many steps, are there any other ways of doing this? Are there any other questions that you could create by using this context, by using these same numbers? Because again, it's all about finding those ways of extending and making sure that they have a deep understanding rather than rushing to find an answer. I won't talk through each and every step on this page. It is here. Please do press pause if you would like to have a look at it in more detail. But again, just to highlight the fact that we would encourage that collaboration, that discussion around the different steps, whether there are alternative ways of doing it and getting the same answer, and what works, what wouldn't work. Again, working towards achieving that mastery understanding of concepts, skills, and knowledge. To summarise what we've discussed today then, the 3 reads problem solving approach focuses on developing the student's understanding of the language and vocabulary behind a question, as well as understanding the numbers and the mathematical structure of problems. Equally, it encourages them to focus on methods and developing their reflection on the difference between efficiency and accuracy, rather than rushing to get answers. This is going to promote success and a growth mindset for all students, as all students will be able to engage in at least one, if not all stages of this problem-solving approach. This is also going to be an extremely useful tool for our teachers, who will now be able to identify where the challenges and potential misconceptions lie when problem solving. For example, if students are finding step 1 challenging, that suggests to the teacher that there is a need to discuss and revisit previously learned and new or tricky vocabulary to ensure that the students have that understanding. If there is a challenge at read 2 or step 2, this would suggest to the teacher that there is a requirement to discuss the difference between parts and wholes and how to identify whether a number is a part or the whole amount. And then if there are misconceptions and challenges within the 3rd stage, that will be helpful for the teacher to identify whether there was just a small error made within the calculation, but knowing that the students have got a good understanding of that concept, or it may also identify to the teacher that if it was a division question, for example, there is a need to revisit the strategies and the methods associated with division. So I hope that this session has been helpful for you. If you have any questions about how we are teaching problem solving moving forward or maths in general, please do feel free to reach out and email me at any time. I have included my email address on this slide. Thank you again for joining me, and I look forward to seeing you all soon.